Hi guys, welcome back to CNC Island. The moment has come for us to test our T-Track hold-down clamp kit in action, as promised at the end of the last video. But first, we need a dust collection system so as to not suffocate in our workshop. In its simplest form, the dust collection system includes a dust collector, a hose, and a dust shoe. We bought a dust collector from the Harbor Freight store and made it wall-mounted in this way. It turned out convenient and compact. The dust collector doesn't take up much space. Now we need a dust shoe. Our spindle motor is 80 millimeters in diameter, so a shoe is specifically needed for this size. We found such a dust shoe on eBay. It has an 80 millimeter diameter for mounting to a spindle motor and 100 millimeters, or approximately 4 inches, for connecting a hose. Perhaps this isn't the best solution, but this shoe seemed affordable, convenient, and reliable. The front of the shoe is easily detachable and removable with the hose, so changing the end mill tools is convenient, quick, and easy. The dust collector came with an adapter from 4 inches to 2.5 inches, so we decided to buy another one and use a thinner 2.5-inch diameter hose. For the first test check, we decided to make a small wooden fresco, 7 by 9 inches in size, but with a high-resolution picture. Take a look at it. We're going to try to make something close to this quality. We believe that if the machine can handle this task, then it'll also cut larger workpieces as accurately and successfully. As a material, we use a select pine board, which can be bought at Lowe's or Home Depot. Poplar is probably more convenient for engraving wood, but we decided to see how pine wood would work in our case. We fixed the board to the table using the T-Track hold-down clamp kit. We decided to do the cutting in 2 steps, a rough pass and a finish pass. For the rough pass, we use this end mill, 2-flute milling cutter for aluminum, which also perfectly processes wood. For the finish pass, we use this end mill. If you're interested, let us know in the comments and we will send you our G-codes, which are designed specifically for these cutters. So the workpiece is fixed, zeros are set, start the rough pass. The spindle motor is set to 20,000 RPMs. As you can see, the cutting is going well and seems to be going fast enough. A bit noisy from the running spindle motor and from the working dust collector. Leach-Wan servo motors operate almost silently compared to conventional stepper motors, but with such a noisy background, it is difficult to evaluate the noiselessness of our axial motors. The machine cuts the wood quickly, accurately, and confidently. We're happy with how the rough pass went. We want to make a small digression and ask you, our subscribers and viewers, do you think it's necessary for us to indicate in detail where and for how much we bought the corresponding accessories and materials? We do this only because we want to save you the time that we have already spent doing research for everything we need. If you believe that we're doing this in vain, please let us know in the comments. The initial pass is completed. It lasted a little more than 40 minutes. We move on to the final part. Changing the cutter, and go. The spindle motor is set to 20,000 RPMs. As you can see, the finish pass proceeds according to a different scheme. It works more like a 3D printer, but we chose this mode ourselves when generating the G-code. The final part is also going well. We added a little speed to the movement of the axes because each step on the y-axis is only 0.2 millimeters and the whole cutting process lasts a very long time, about 6 hours. We don't want to wait that long. We'll have to think about a transparent dust shoe to see what's happening under the shoe during cutting, but that's probably not very necessary. A check of the spindle motor temperature shows that by the end of the finished pass, the antifreeze temperature rose to about 140 to 150 degrees Fahrenheit. That's quite normal, especially keeping in mind that we filled only one 1-gallon bottle of antifreeze into the cooling tank. It'll be necessary to fill in the second one, then the temperature will be much lower. Our cooling system works well. And the 12-volt water pump with the voltage supply reduced to 5 volts easily handled the task. We won't bore you with the whole lengthy process, and we'll just show you what we got in the end. Not too bad. To bring the fresco to the desired state, paint or varnish will be needed. And this is how it looks after all our improvements. Not bad at all, right? Let's compare our results with the design we were striving for. We think it turned out very well. Not identical, but very close. So to summarize, the machine we selected and assembled is quite suitable for woodworking. The desktop, as a stand for the machine, is durable and sturdy. The Lichuan servo motors work very well. They barely heat up and they don't lose steps, as stepper motors sometimes do. And the M16D board from CNC4PC.com is simply gorgeous and flawless as always. Perhaps we'll try to remodel our kitchen cabinets in the future. Only the doors need to be replaced. You see, for 24 years old, our kitchen isn't looking too hot. The decorative film on the doors has cracked and partially peeled off. Let us try to choose the appropriate wood and find patterns that work with the kitchen theme. The dimensions of our CNC router allow with a large margin for engraving doors of such sizes. Thanks for watching. See you soon with the PM727 project.